Dear learners, Namaste. I am Dr. Shailendra Kumar Sharma. I am teaching as Assistant Professor in Government Model Degree College, Saharanpur, Uttar Pradesh. Prior to joining this college, I have been taught in a constituent college of University of Delhi for around 7 years. Topic of this session is Mann-Whitney U-test. We will try to understand the concept of Mann-Whitney U-test along with assumptions, limitations and other basics. Then further we will learn to compute Mann-Whitney U-test for a small sample during end of this session. So let us begin the basics of Mann-Whitney U-test. Mann-Whitney U-test was developed by scientists Mann and Whitney. These were two scientists who developed this test. The Mann-Whitney U-test is a common statistical test that is used in many fields including economics, biological sciences and other behavioral sciences. Mann-Whitney U-test is a powerful non-parametric test and an effective alternative to independent t-test. As we know, non-parametric tests are methods or tools of statistical analysis that do not need a distribution to meet the required assumptions to be analyzed, especially if the data is not normally distributed. Due to this reason, they are sometimes referred to as distribution free tests. Non-parametric tests serve as an alternative to parametric tests such as t-test or ANOVA that can be employed only if the underlying data satisfies certain criteria and assumptions. Mann-Whitney U-test can be used adequately with variables that are continuous and discrete and can be effectively used with a small sample. Though in terms of power, it is less powerful. As already I have talked about that this is a non-parametric test. So automatically it would be less powerful in comparison to parametric test. But its power is higher than other non-parametric tests like median test. Mann-Whitney U-test can be applied to find out whether two sample subgroups have been taken from a same population. It also helps in determining the distribution of data with regards to its median. So this test is used to investigate differences between two independent groups when the dependent variable is either ordinal or continuous, but not normally distributed. For example, you could use the Mann-Whitney U-test to understand whether attitudes towards pay discrimination, where attitudes are measured on an ordinal scale, differ based on gender. That is, your dependent variable would be attitude towards pay discrimination and your independent variable would be gender, which has two groups, male and female. So let us take another example. Suppose a psychologist is interested to study if significant difference exists between junior and senior managers in an organization with regard to their life satisfaction at workplace. The researcher, in order to achieve the objective, researcher collected data using a standardized psychological test for life satisfaction and then had to carry out a statistical analysis of the data. Initially, psychologists felt that independent test t-test cannot be used as the assumptions of parametric test were not fulfilled. Be remember always, if we are using suppose a kind of non-parametric or parametric, we should keep in mind that assumptions of that particular test should be fulfilled. So, therefore, in this particular example, the researcher decided to use Mann-Whitney U-test. Non-parametric test t-test is not fulfilling the assumption. That is why he has decided to go with Mann-Whitney U-test for statistical analysis. So, let us now discuss about the assumptions of Mann-Whitney U-test. What are the assumptions of Mann-Whitney U-test? First assumption of this non-parametric test is the observations need to be independent in nature. It means measurements for each sample subject are in no way influenced by or related to the measurements of other subjects. For example, there must be different participants in each group with no participant being in more than one group. This is more of a study design issue than nothing you can test for, but it is an important assumption of the Mann-Whitney U-test. If your study fails to this assumption, you will need to use another statistical test instead of Mann-Whitney U-test. So, be remember always. So, this is the first assumption we have about Mann-Whitney U-test. Second assumption is dependent variables should be assessed at the ordinal or continuous level. Examples of ordinal variables include Likert items. You know about Likert items. For example, a 7-point scale from strongly agree through to strongly disagree. Other ways of ranking categories, for example, a 5-point scale explaining how much a customer liked a product, ranging from not very much to yes or a lot. Examples of continuous variables include revision time measured in hours, intelligence measured using IQ score, exam performance measured from 0 to 100, weight measured in kilograms, and so forth. Third assumption of Mann-Whitney U-test is the data are assumed to take a non-normal or skewed distribution. If your data are normally distributed, the unpaired student t-test should be used to compare the two groups instead. Now, the fourth assumption is while the data in both groups are not assumed to be normal, the data are assumed to be similar in shape across the two groups. This is the third assumption of Mann-Whitney U-test. While the data in both groups are not assumed to be normal, the data are assumed to be similar in shape across the two groups. Now, the fifth assumption is the test is used when the two sample subgroups are independent and data is ordinal. In case if data is in interval or ratio form, then the same is converted into rank order. This is very important, we have to remember. While computing Mann-Whitney U-test, or while we have taken decision to go with Mann-Whitney U-test. And the sixth assumption is the sample subgroups need to be independent and not correlated. Example of such variables that meet this criterion include gender. Gender has two groups, suppose for example male or female. Employment status, suppose it has also two groups, employed or unemployed. Suppose we are taking another example, smoker, it may have also two groups, yes or no, and so forth. So, these are the different assumptions of Mann-Whitney U-test. Now, let us discuss about the advantages of using Mann-Whitney U-test. First advantage is this non-parametric test tells whether the difference is significant or occurred by chance. So, this is the first advantage. That is why we go with Mann-Whitney U-test. And second assumption is it also tells about the median between two sets of data. Third is you can use data sets of different sizes in Mann-Whitney U-test. In other words, an advantage with this test is that the two samples under consideration do not necessarily need to have the same number of observation or instances. The fourth advantage is this test is appropriate in dealing with skewed data. So, data does not need to be normally distributed, as we have already discussed. And the fifth advantage is this data is based on the idea that when m number of x random variables and n number of y random variables are arranged together in increasing order of magnitude, the pattern they exhibit provides information about the relationship between their parent populations. So, these are different advantages of using Mann-Whitney U-test. Now, let us discuss about the limitations. Any test has certain limitations. The first limitation of this Mann-Whitney U-test is these tests have a lower power than parametric test. This means that if there really is a difference between two groups, these tests are less likely to find it. Second limitation is it does not explain why there is a difference. Third is it is more appropriate when the data sets are independent of each other. And the next limitation is it is more appropriate when both sets of data have the same shape distribution. And last but not least limitation is become less accurate when the sample size is below 5 or above 20. Now, let us talk about computation of Mann-Whitney U-test for a small sample. When we have a small sample, so how we compute Mann-Whitney U-test? Suppose the example is a psychologist wanted to study whether gender difference exists in students with regard to mathematical ability. The sample size was quite simple, as each of the sample subgroup had less than 8 participants. In such a situation, Mann-Whitney U-test for a small sample can be computed, and the data is given in table number 1.1. So, let us learn how Mann-Whitney U-test can be computed, or the value of Mann-Whitney U-test can be computed in this context with the help of different steps. As you can see here, these are the mathematical ability scores of male and female students, which are presented in table 1.1. In males category, mathematical ability scores are 6, 13, 7, 11 and 5, and sample sizes, as you can see here, sample size is 5. And in females category, the scores of mathematical ability are 10, 16, 12, 14 and 70, and the total sample size is same as first one, means it has also sample size of 5, n is equal to 5. So, now let us proceed with step by step about the computation of Mann-Whitney U-test. So, the first step of computation of Mann-Whitney U-test is null hypothesis is to be formulated. In any kind of statistical analysis, especially inferential statistical test, we should formulate null hypothesis. As we know, null hypothesis directs our research. So, the first step of this Mann-Whitney U test is we have to formulate null hypothesis, and the null hypothesis is of this particular example can be formulated like there is no difference between males and females with regard to mathematical ability. And what would be the alternative hypothesis? There would be significant difference between males and females with regard to mathematical ability. This would be alternative hypothesis. So, now let us talk about step number 2. After step 1, we have to go with step 2. Step 2 is about arranging the scores obtained by males and females in an ascending order, that is from lowest to highest. Lowest to highest, ascending order. First, we have to identify the lowest score in the data set. So, the codes for their groups of A for females and B for females also need to be mentioned, and the lowest score is 5. After that, the higher than 5 is 6 in data set, and then 7, 10, 11, 12, 13, 14, 16 and 17. So, this is a kind of ascending order set, and 5 A for females, as we have talked about, A denotes to males and B for females, and against each score their symbol is mentioned, like against 5 A is there, against 6 A is there, against 7 A is there. Similarly, against 12 B is there, because it comes from females category, that is why we have denoted B, and 13 A, and 14 B, 16 B and 17 B. Now, let us discuss step number 3. In step number 3, what we have to do? We have to compute U. U is computed. U is what? Mann-Whitney, the value of Mann-Whitney U test. This is for sample number 1, U. So, this is done by determining the number of scores for A males and are falling below the scores of B, that is females. So, this is done as follows. For the score in group B of 10, the number of scores, as you can see in a previous table in data set, the number of scores from group A that falls below 10 is equal to 3, and for the scores in group B of 12, the number of scores from group A that fall below 12 is equal to 4, and for the score in group B of 14, the number of scores from group A that fall below 14 is equal to 5, and for the score in group B of 16, the number of scores from group A that fall below 16 is equal to 5. For the score in group B of 17, the number of scores from A that fall below 17 is equal to 5. Thus, let us compute U. U is equal to 3 plus 4 plus 5 plus 5, just these are the values just we have computed, 3 plus 4 plus 5 plus 5 plus 5, and the total would be 22. Now, let us also compute U dash, and this is the value of second population. So, for the score in group A of 5, the number of scores from group B that fall below 5 is equal to 0. For the score in group A of 6, the number of scores from group B that fall below 6 is equal to 0. For the score in group A of 7, the number of scores from group B that fall below 7 is equal to also 0. For the score in group A of 11, the number of scores from group B that fall below 11 is equal to 1. For the score in group A of 13, the number of scores from the group B that fall below 13 is equal to 2. So, let us compute U dash, and the total value would be 0 plus 0 plus 1 plus 2 is equal to 3. So, thus U is equal to 0 and U dash is equal to 13. Further, the total of U and U dash needs to be equal to N1 multiplied by N2. Thus, so let us compute it. U plus U dash is equal to N1 N2. So, this is the another way of checking these values. U is equal to N1 into N2 minus U dash, and the value would be 5 into 5 minus 3, and total would be 25 minus 3 is equal to 22. So, the value obtained is 22, and it is same as the value obtained earlier using the formula. So, now let us talk about step 4, and this is the final step of computing Mann-Whitney U-test when data sample is small. Step 4 is interpretation of the U value. To interpret the obtained U, the table for U is to be referred to, and that can be found in appendix section of books of statistics. In our example, N1 is equal to 5 and N2 is equal to 5, and the U is equal to 22. The table value in this regard is 0.579, and the U obtained by us is more than the table value, and thus null hypothesis can be accepted, and it can be said that the samples have been drawn from the same population. So, this is the decision we have taken based on the value we have obtained. So, this is the finding of this particular example. We have to always remember that in non-parametric, this particularly in Mann-Whitney U-test, we have to remember is if our obtained value is greater than table value, then we have to accept the null hypothesis, whereas in parametric test, if obtained value is greater than table value, then we go with alternative hypothesis. So, this is all about the basics of Mann-Whitney U-test and how we compute Mann-Whitney U-test when data sample is small. Thank you.